So hello guys, welcome to my channel. So now we will start a new question. The question name is note at a given distance in binary tree. So it is a hard level problem. So we will see how we will tackle this question. So let's go to the question. So given a binary tree and a target node in a binary tree. Okay. So and a integer value k. So we have three things. So firstly binary tree, and after that a target node. So target node means one node that is present in the binary tree. Okay, after that a value of k, so that is integer. So find all the nodes that are at distance k from the given node. So we have to find all the nodes that are present at k distance away from the target node. Okay, let's see in the example. Okay, so no parent pointer are available. No parent pointer are available. So we have to note two things. You have to return a list in sorted order. So after that we got the remaining element. So you have to return into sorted order. After that array will not contain any duplicate, and the one more thing is tree not contain and duplicate. So let's go to the example. So this is example first. So this is the tree. So we have to find so they give us a target node 8. So this is 8. So this is 8. After that value of k means 2. So basically k means moves from 8. Which element is present from 8 in 2 moves. Okay, like from 8 to go to their parent, this is one move, and after that go to this 22, it take 2 moves. So and our value is k, so that's why 22 is print. And when we go to into the right side, it move 1 and k value is 1. So after then go to the this 14, k value is here 2. It will be it take 2 moves. So k value here it is 2. So after that k value, when we go to this standpoint, k value is 2. So that's why the output is 10, 14 and 22, because we have to print in ascending order. So in sorted way. So that's why 10 to 14 and 22. So because why this output we have get, because they give us a k value, and that's why we have to reach this point only when we move k's. Okay, because from 8 it take 2 moves to reach for 10 and 10 and 14. So that's why the explanation is said that the 3 nodes at a distance 2 from 8 are 10, 14, 22. So there are 3 nodes present in the tree that are the distance from the 8 node is 3. So this is 1, 2, this is 2. Okay, I hope you understand what the question said. So next example is given node is 7 and value is k value is 2. So we can see only 1 and 24 is the output. So the expected time complexity of n power n into log n, and expected auxiliary space is height of a tree. Okay, so let's go to the notepad and let's see what is the approach behind this question. So this is the question. Note at a given distance in binary tree. So we have already seen the question. So this is the tree. Okay, so firstly I zoom in this question. So this is the target value. Okay, this is the target value. So first step is to find this node. Okay, to find target node, they give us a value of target node as they give us target node is 8. So we have to find traverse this tree and return the target node. So we simply return this out. We have formed some algorithm. So after that it return this 8. Okay, it's 8. So first step is this. So let's think how we will approach this question. So what is the approach behind this question? So this is the prerequisite before to going to solve this this question. It is level order traversal. If you don't know the level order traversal, so you go through level order traversal and understand the basic concept of level order traversal. So after that you will be able to tackle this question. So I hope you understand. After that, so this is our tree. So let's see how will we approach to handle this, to solve this question. So first step is to store the head of every element, every node in the binary tree. So as we see that there is no head of 20, but there is a head of 8. So we simply store the we using first step is hash map. We take a function so in which we store the parent. Okay, hash map, we are using hash map, so that's why we are using. Firstly we store 8 and its parent 20. Yeah, 8 is complete and its parent is stored. Yeah. Okay, after that 22 and its parent 20. After that 4, its parent 4, 8. So like this, there is other some cases like after that 12 and their parent 8. Like this, we are storing all this parent of all node. Okay, this is the first function that only store parent of the node. Okay, of every node. So this is the first step. After that you have to find, as I already said, you have to find this target node. Yeah, find this target node so you can simply solve this question through this from target. So as I mentioned that you know the basic idea of level order traversal. So now we will start how to solve this question using level order traversal. So as we are using level order traversal, so we have to use queue. Okay, so in level order traversal we are using queue. So third step is function level order traversal. Okay, so this function, so firstly we push their left side and right side. After that parents, but one condition is there, so parent is not visited. So this is the third step. So let's go to the try and run and check how we will able to tackle this question. Okay, so firstly this step we have to only put the element, put the parent of every node into the hash map. This we have done. Okay, after that we have to find target node value. Okay, so we will see how we will see the target value. So let me firstly go to the after that this is our queue. So in level order traversal we use queue. So firstly we put 8. Okay, simply put 8 into the queue and count is equal to count is equal to 0. Okay, count is equal to 0. After that putting count is equal to 0. So to check if count is equal to k or not. Okay, so if this condition happen, so simply break the loop. Okay, after that putting 8 into the queue. So we're using for loop for what size. All size is n is equal to power n is the size of the cube. So now size of the cube is 1. So simply for loop is executed into n time. So this for loop is executed. So as I mentioned that we are using level out reversal in this answer in this question. So simply we are store temp value is pull from queue. Okay, poll. Okay, this temp is poll. After that, this is the condition I have to check. So if temp dot left is equal to not null, so temp is here. Now temp is 8. So temp is 8. Temp point to 8. Its left is not null, so it is not null, and map dot contain temp dot left. So it simply means that it should not be visited before, because if we visit this 1, so we have to maintain our record so that we don't visit again. Okay, so simply check this condition is checked. It should not be visited again. Okay, so if this condition is satisfied, this both conditions satisfied, simply add left, and its left add is 4. After that, same condition for, but one more thing, we have to choose a hash set. Okay, hash set. This is map 1 means hash set. So we simply add choose a hash set. So simply write a hash set and store here 8. Choose here 4. First we are storing 8 here. After that we are visit 4 here. So simply put 4. So put this is the left side, and this is the same for right side. This function is same for right side. So simply put 12. Yeah, that I am using this logic, that is the third step. Okay, firstly left or right. So left or right, check for left or right. After that parent, check for parent. So after that we are simply dot cat map dot cat. So in this map, as first step, we simply we used to use this function for storing its parent. So that's why after that left or right, and we visit its parent means its parent is 20. So we get this parent from this function hash map. So this map dot get temp means that value. So its parent we are storing in the map. So that's why it gives us its parent. So it gives us 20. Okay, this 20. Yeah, this 20. After that we check if it is not null. It should not be null. One conditions, and it should not be visited before. I hope you understand. We have to check if it is visited or not. So this 3 condition is used for visitor or not. This is hash set. We are using map dot map 1. So that's why you are confused, but it is hash set. So it should not it only contain different values. Okay, not same value. So after that, if it is this condition satisfied, simply add into the hash set. So what is the set? It's parent. What is the parent? Its parent is 20. Okay, and store 20 here. Yeah, 20 here store. As I said that this for loop is executed n times. So when one time is executed, so as 8 is popped from this cube, so after that next loop the size of the cube is 3. So size is now size is 3, and again the value of count is 1. We increment the value of count 1 is 1. So yeah, so after that same repeat condition is happen. So pop this element and check if there is a 4. This is a left or right? No, there is not a left and right. So store, and after that check for 8. Yeah, there is a element of 8, but this condition is not satisfied because it contain again it contain already in the hash set. So we have already visited this before, so that's why we did not take any element from this side. After that this 12 and the left side and right side of 12 is 10, 14. Also store into the hash set. So and its parent 12 parents is 8. So we already visited 8. So don't store 8 here. So this condition satisfies. So this is 12. After that 20 is come. So 20's left is already visited, so we don't take this node, and 20's left right is not visited, so simply push into the cube. Also push into the hash set. Okay, so now it's 20, so that's why the size of the cube is 3. So this for loop is executed, so this 3 element is popped, and remaining element is 10, 14, 22. So size is again 3. So that time count is 2, which means that element present in the cubes. So its distance from element 8 is 2. So after available element, remaining element in this cube is the output of the given question. So as we say that, as we can see that 10, 14 and 20. So we simply check here one condition. So if check this condition, so if k is equal to c, count means k2 means is equal to 2, so that's why we simply break from this loop and simply print the element of this cube. So this question is very easy, but as we can do in steps. So this question is very easy for us, but the code of this question is very long, so don't be afraid because code is very long. So but logic is very simple. You have to think only logic. You don't be scared about what is our code length. Okay, let's go to the code. Yeah, so this is over. 1 minute. This is our given method public. We have to return array list, so that's why return type is array list, and they gave us a root node in target value and k value. So after that we create a hash map for storing parent element, okay, for storing node parent of node, okay. And this is the find current method. So this is the current method, means quite simply find the current element, target element, okay, target element. Simply why I use the recursion here. If root is null or root is data is equal to target, simply this return this element, okay. After that, go to the left side. If left side is return not null, simply return left element, okay. Return right side, yeah. So this function help us to find the target value. So it is mandatory, it is guarantee that target node is present in the binary tree. So at that time, when this condition is triggered, so return that element. So at that time we have to return in this case we return 8 here, 8. So from this function we return current value, target value from this function. After that, this is the target value function. After that, mark parent. As I said that mark parent means store the parent element of the node, okay. So this is the mark element function. Simply traverse this tree. So simply root is returned, so it simply return if root dot left is not null. So simply push that is left element, left side, and simply is parent means root, okay, and simply go to the its left side. This is recursion. So if there is a left element, so simply in the left side key value is its left element, and right side its parent. So simply I write this hash map is store the parent. So this root is parent of this left element, and go to the left side. This function go to the left side, and after that this is the far right side, same. And in this case we simply store right element node into the right side. Right element of node is right side, and parent of this node is right left side, okay, yeah. And calling to right side. This function is generally store the parent of the given node, yeah. We have completed these two function, this first, second, okay. So this two function is completed. After that, this mark parent we have completed. So this function, yeah, level order traversal, okay. We have passed current element and passed map. That map are used for store parent and k value. K means given value, k value means distance value, okay. So as they said that we are return array list, so simply we have to also return from this array list into array, yeah. This element, this function is executed for the code. So simply return type is array list. So as mentioned, it's required return type array list. So array list is the return type. So this is the current node. We have to find this above current find node functions. This map used for find parent and int value, okay. We are using hash set for storing. We are checking if it is visited or not. Hash set, I mentioned that in the notepad. After that, we simply use queue. Why are we using queue? Because we are using level order traversal. So we are in level order traversal we are using queue. So that's why I take queue. So after that, array list. So array list, as the return type is array list, so simply I am using array list for storing the element, okay. Simply in outside I return count 0, and first I add first element, root element. After that I add into the hash set, so it is visited firstly. So simply go to the while condition. This is the same for level traversal. So after that find the size of the level, this cube. So firstly it's the size of the cube is 1, so that's why it executed only one time when it is 8. So check if count is equal to k, so simply break. As I said that this condition is satisfied, if this condition is satisfied, simply break. So and increment of count 1. Okay, so simply k is equal to, this for loop is going to n time, means size of the cube. So it is firstly it goes to 1, after that it goes to 3, like this. So simply pop this element from the cube and check is left or not null, and it should not be visited before. So this is satisfied. So simply add into the cube and also add into the hash set. So this is left side, this is for left side, and this is for right side. And in this node we are checking, we are get parent node of the given node that are pulled from cube. Okay, and check here, it should not be visited before, so that's why, and it should not be null. So this condition is also satisfied. So and go to add into cube, and I also add into the hash set. So this process executed and at a particular time count is equal to k. So simply break this loop, while loop, and if count is equal to k, simply find the size of the cube and simply find the element and pull from the cube and simply add into the array list. Okay, after that, as the question said that it should be in sorted order, so I simply collection dot sort is equal to it should be sort, and return is the array list. Okay, this function is return array list, so return type is array list, and I call here into main function return. So it return array list, so it also required array list. So this will execute. So let's go and compile this question. Yeah, it compiled successfully. So let's go to submit this question. Yeah, it successfully submitted. So I hope you like my video. So if you don't understand well, so go to and see my video again. So thank you guys. Okay.